So hello guys and welcome to my channel. Today again I am back with another important numericals. So here we have given the numericals, and here this numerical was once asked in 2018 spring in transmission and design subject. So here you can see in the questions we have given as 90 megawatt distance with 200 kilometers and 132 kilovolt single circuit line is given, and the conductor different conductors and its economical span is also given in this column. Similarly, the cost of tower per unit length for each conductor is also given, and the cost of aluminium per ton is given as NRS as 2150, and also the cost of steel per ton is given as NRS as 1,50,000, and loss factor is given as here 0.5. Similarly, we have given, or here we have assumed the value of K1 and K2 as K1 as 0.7 and K2 equal to 0.3, and we have to calculate the most economical conductor here, and also per unit energy cost NRS equal to 8 given in the questions. So let's start the solutions. So the very first step we'll do here we have the formula to calculate the cost of conductors. So to calculate the cost of conductor, here we have the formula 3 into weight of aluminium means Al here, this means weight of aluminium into 20.15 plus weight of steel into 150. And here for different conductors, here we have given sheep conductors, similarly kundan conductors, deer, and here we have zebra. So for different conductors, the value for R75, similarly its weight for weight in kg for aluminiums and weight in kg for steel, here we have given as, here you can see in the table. So here sheep conductors, similarly have kunda conductors, similarly here we have deer, and similarly here we have zebra. So for sheep conductors, here we can see the value for this is for R20 and this is for R75. So its respective value will be for R75 0.09498. Similarly for kunda it is 0.0908. Here we have this value. Similarly for deer, here we have this value, and similarly for zebra the value for R75 is this, and here we have used this value for R75 here for sheep, kunda, deer, and zebra. Similarly, the weight in kg for aluminium and steel is also given in the table, and here weight in kg for aluminium and steel. So here its respective value will be, for aluminium here we have 1036, similarly for steel we have 690, and similarly here we have 1120, 162, 1188, and similarly for steel we have this, and similarly for zebra here we have 1185 and 438 for steel. So here we have used all the value from table. So these all values are obtained from the tables. Now we have just in the first step we have used the formula as cost of tower as 3 into weight of aluminium into 20.15 plus weight of steel into 150. So if you use this formula you will get the value of will get the value for cost of conductors for sheep. So if you calculate for sheep, we'll get the cost of conductor as 373,126.2. Similarly for kunda, here we have this value. Similarly for deer, we'll get the cost of conductor means the cost of deer conductor is 426,864.6. Similarly for zebra, the cost of zebra conductor is here 26,8733.25, and the cost of aluminium per ton is given as R is equal to 2150. This is an aluminium per ton, but if you calculate in per kg you will get here 20.15. Similarly, the cost of steel per ton is 1,50,000. So you will get here 150 per kg. Now the cost of tower per unit length, and here the cost of tower per unit length is already given in the questions. Means here the cost of tower per unit length in is given in the questions. So just we have copied this value in the next page. Just copy this and paste here. So we have just here we have just copied that value and here we have pasted this. And so for ship conductor here R75 is given as 0.0926 ohm per kilometers. So here we can see in the table, just now we have obtained from the table as ship conductor is 0.09498 for R75. And here, so to calculate the value of I, we have I is equals to 90 megawatt given, so 90 into 10 power 6 upon root 3 into 132 kilovolt, so 132 into 10 power 3 into power factor is 0.9, so you will get at 437 ampere. Now conductors here, respective conductor is given as for sheep, kunda, deer and zebra, and peak power loss is given as 3I square into R, and 3I square into R in place of R we will use R75. So for sheep we will use R75 as this. Similarly for we can use R75 for kunda as in the previous from the previous table. So if you can use this formula 3I square into R, now I will be fixed and only the R will be variable here, means R75 for sheep, similarly R75 for kunda, similarly R75 for deer, and similarly R75 for zebra. So if you calculate peak power loss, you will get the respective peak power loss for each conductors. Now average power loss. So average power loss is calculated as loss factor into peak power loss watt per kilometer. So loss factor is given in the question as here. Loss factor is given as here 0.5. So you can directly solve with the calculators. You can directly set all the parameters in the calculators and just you can solve with the help of calculators. So loss factor into peak power loss, and just now we have obtained the peak power loss and the loss factor is given 0.5. So average power loss for each conductor will be calculated here. So similarly for kunda, deer and zebra we can obtain the average power loss for each conductor. And the cost of energy loss equal to average power loss into 8760 and RS8, means here in the questions here we have given per unit energy cost is NRS8. So the cost of energy loss equal to average power loss, just now we have calculated average power loss into 8760 into RS8. So if you calculate individually we will get all the values here for sheep, kunda, deer and zebra conductors. Now to calculate the total cost will be the cost of tower per kilometer plus cost of conductor per kilometer plus cost of energy loss, and cost of tower per kilometer, so cost of tower per kilometers, and here we have the value for cost of tower per unit length. Similarly cost of conductor per kilometers, cost of tower per kilometer, cost of conductor per kilometers, and cost of energy loss, and here this is the cost for energy loss, and we have obtained all the value. So for total cost just we can sum up this value, means cost of conductor, this value and this value means cost of energy loss. So for sheep we will get here this value means 1910762652. Similarly for kunda we will get this, similarly for deer and similarly for zebra. So finally you can conclude that here the minimum cost is IS 16693103924 for deer conductors, and which is in the here this deer conductors. So the minimum cost is RSA. So deer conductor is the most economical conductor here. So we conclude deer as the most economical conductors. So thanks for watching and please don't forget to subscribe to my channels. Hope you enjoy the lectures. Thank you.